Hello everybody, thank you very much for joining today. My name is Sam and I'm going to be talking to you about CICD pipeline security. So just to begin, let's run through the introduction slides because it's first thing in the morning. So I'd just like to thank Rob, Linda and all of the other volunteers who are making this possible today at DDD. This is the first time I've had the main event. I've done a couple of the kind of local ones before, but it's really good to be here, albeit virtually. Just like to make you aware of the kind of the house rules today. As usual, the kind of be friendly, be inquisitive, be welcome, be respectful, all the usual applies. And the team are basically doing this for free, but they are asking for donations to the National Museum of Computing, which helps preserve the legacy of computing. So if you do have some spare change, you can always chuck it that way. And the event is also made possible thanks to the generosity of the sponsors. If you want to follow along, then you can do so on the hashtag DDD20 or using the Developer Day Twitter account. Okay, so on to me. As you can tell from the accent, I'm Geordie. I've been doing software development for about 10 years now. I've been working at Tesco Bank since May, which was a very interesting onboarding experience. I've been in the office like 3 or 4 times. The talk today is mostly based on a previous contract role I was doing earlier in this year, where I was working for a large UK financial institution. You would have heard of them, and I basically had to build the DevOps and CI/CD pipeline out for an MVP in a very short space of time. Naturally, I made a lot of mistakes, and this is what the talk is about. I'm also the weird Halloween kid on the street. And by that, I mean, this was my house this year. We really go all out. As much as I'd like to talk about Halloween, although I am wearing Christmas garb today, I do want to talk about security. So let's get the business buzzword out of the way. In the DevOps community, we have this idea about bringing the development and the operations together. The idea here is that we are trying to integrate these concerns, align them and bring them earlier into the process where we can think about both building and running and operating our software in production. Now, naturally, security comes into that as well. The idea of DevSecOps is that you're not just leaving security to the end. Just before you go to production, you do a pen test. Actually, you are shifting security left, that is, embedding it throughout your process, because the earlier that you can get feedback on any kind of issue, whether it's a security issue or whether it's a bug in your software, the earlier you hear about that, the cheaper it is to fix, the quicker it is to fix, and the less damage that causes. We talk about continuous integration, and CI is the practice of integrating our code on a regular, ideally daily basis. And what we need in order to support development at that pace is some kind of automated process. And historically, this has involved something like Jenkins, where you would run automated tasks to build your software and to produce a binary and then stick that somewhere. The idea of continuous deployment, the CD part, is to take that automated process further and use these tools that you build to not only compile and test your software, but also to deploy it into a development or a QA or a production environment. What you're basically building with a tool like Jenkins or GitLab, GoCD or GitHub Actions is a value stream. It's a way of delivering your software. It's ultimately the way that software gets in the hands of users. And for that reason, this becomes a very important part of your software delivery. It's the beating heart. And that means that it's not only your application that needs to be protected and secure, but also the delivery pipeline too. Now, we can apply the concept of threat modeling. We can think about where are these risks going to come in and what steps can we do to mitigate those risks. Naturally, we can think of external threats, people who want to steal our source code or get access to binaries. I mean, if we charge for our software, naturally people will want to try and get it for free. but they may also use the pipeline as a way of exfiltrating data, or actually being able to push malicious code into a production environment. You hear stories literally every week about applications which have been modified to run some kind of Bitcoin mining process in the background. When people can access your code, they can run their own code as well. But it's not just external threats we want to be concerned about. We also have to be concerned about internal actors too, whether they're inadvertent or whether they're malicious, like Mr. Nedry over here. These have all the same threats as external actors, but the difference is they have added knowledge. They're probably the ones who built or run this software, so they know how it's all strung together. So you need to think about, well, what happens if somebody internally decides to maliciously use this pipeline? What happens if they want to just put a local build which has various features turned off, or some malicious piece of code in it, and throw that all the way to production? The type of thinking that you can apply when considering these threats is stride. You can look at spoofing, tampering, repudiation, which is, can you tie back actions to an individual? Information disclosure, denial of service, and elevation of privilege. So these are the kind of supply chain attacks we're really looking at here. And I want to kind of apply this in two contexts. So the first one is, how can we use the CICD pipeline to secure the application itself? And this is basically using a bunch of automated processes to inspect the quality of your application and to prevent certain things making themselves apparent or making their way out the door. So the first one is secret detection. The last thing you want to do is to be checking in things like API keys or private keys into source code, because once it's in there, it is an absolute pain to remove, especially if you've pushed it. So rather than detecting this once somebody manages to nick your source code, what you can do is you can put in place tooling and processes to stop this being committed in the first place. So a really good example is there's a tool called Git Leaks. You can run this locally on your machine as a pre-commit hook, or you can run it on your shared source repository as a pre-receive hook. And it can detect if you try and commit something that looks like a private key or a client ID or something like that, and it will reject the commit. So this stops secrets getting into your application source code in the first place. And then that encourages other and better practices around, well, if I can't just check this code in, how else can I inject secrets? And we'll come to that a bit later on. I was talking about the software supply chain because we don't build software in isolation. We rely on a huge number of third-party components and libraries which come from the internet, and we need to think about how secure are them. And in order to answer a question about how secure is our application, we need to know about our third parties. So typically what you'd want to do is you'd want to have some kind of auditing process in your pipeline, which looks at your dependencies and checks things like, what licenses do these have? Look against the CVE database. Are there any known security vulnerabilities registered against the versions that we have? And things like guardrails and Dependabot will do this for you and make sure your dependencies are kept up to date. A tool that I've used in the past as well is Black Duck, and that gives you a kind of traffic light breakdown in terms of, you have some vulnerabilities, these are low, these are medium, these are high, these are critical and need to be fixed immediately. So you can have a little bit of confidence that your application is not being built against known vulnerabilities. The hard thing is when you start talking about DevOps, everybody starts talking about containers. And I really love Docker. I really love containerization. It's a fantastic way to put software in a box, and that box has everything the software needs to run. And as an ops person, all you need to do is know how to move the box around. But that box can make things a bit harder, because if your Docker file is installing some source code, if it's building the if it's running like an npm install inside the Docker container, it becomes harder to understand what's actually going on within the context of your build. Your Docker containers normally start from a base image like Alpine Linux. Is the version of that up to date? Does that have any known vulnerabilities into it? Just like your third-party dependencies, you need to consider the kind of the supply chain of your container stack as well. So there are tools like Claire and Clar, which can kind of take in vulnerability metadata. They can compare what you're building against the database in the same way that you can with things like npm or Nexus or NuGet, and give you that same level of assurance. So that's third-party dependencies out the way. Now we need to talk about your code. So there's kind of two approaches to how you can perform security checks in your code. The first one is running what's called static application security testing. So this is typically running some kind of program like Spotbugs, which knows a little bit about the programming language you're building the application in, and can look at your source code and apply various patterns. So it can say, are there potentials for null pointer exceptions or overflow buffer issues or anything like that? It's looking for these kind of common programmery patterns that often kind of cause security issues if they're hit. Obviously, it can cause a lot of false positives, and it's not going to pick up any domain-specific security issues. So it's not a complete solution in and of itself, but in terms of those, you know, really finicky things, it can typically find these in advance. If you want to delve into the actual application when it's running, what you need to do is then look at dynamic application security testing. So this is where you'd stand up an instance of your application and use a tool like OWASP Zap to actually run a couple of attacks against the application. So Zap is targeted to run the OWASP top 10. So actually the OWASP top 10 security vulnerabilities are the top 10 for a reason, and even to this day there are a huge amount of applications which are still vulnerable to cross-site request forgery, cross-site scripting attacks, SQL injection attacks. So Zap will basically run a few of these against your application and see, like, can I break this? And because it's working against the actual running application rather than just looking at the static source code as presented textually, you can overcome a lot of the shortcomings this way. This doesn't kind of mean I've automated pen testing for what it's worth. It is always still worth having kind of humans who are creative and can apply heuristics and understand the domain knowledge to try and come up with some more creative, ingenious attacks. But actually, if you're interested in covering the OWASP top 10, Zap is fantastic, and tools like GitLab have this stuff built in now for you. So those are a series of processes that you can put in place in a pipeline to give you some assurance that the application you built is relatively secure. Secure is never an absolute, because you're always having to make trade-offs and understand threats and how likely they are against your application. But as I said, the pipeline itself is an asset, and the pipeline itself needs to be protected. If you think about a common pipeline, so here's a one which is running a build step. So it's pulling source code from a repository, and it's then pushing an artifact to some kind of artifact storage like Nexus or Artifactory or Docker Hub. It will run some tests, and it will then perform some deployment steps. And those deployment steps might be sending instructions to a cloud provider to stand up some infrastructure or deploy your app, or even both. So all of a sudden, actually, this pipeline is connected to absolutely everything, which means if I can get to the pipeline, I've got routes to get to your source code, to your databases, to your artifact storage, and to your dev and production environments. So the first question that you should really ask yourself is, where is your pipeline running? Is it standing up in the cloud on some VMs like EC2? If you're running GitLab, is it running on a Kubernetes cluster? Are you standing this up on-prem? What is that system then connected to? Because not only do you have the maintenance and the various vulnerabilities of running your own Kubernetes stack or having on-prem kit connecting to a cloud environment or something like that, it's really important to understand the topology of your network and how everything plumbs together. So on a previous project, I was running GitLab in Google Cloud, and the way we did this was so in GCP, the project is kind of a base unit of billing. So if you have different projects, they accumulate their own billing and they basically become black boxes. So we had one project which was called our shared services, and that's where we stood up our GitLab runners in Kubernetes. It's where we had our container registry, for example. And then we had separate projects for the dev and the production environment. And within each project, they had their own VPCs. So they were all kind of internally black boxed. But in order for the pipeline to be able to issue commands to our dev Kubernetes cluster or our prod Kubernetes cluster, we had to peer all these VPCs together. And what that meant was there was a route from the dev environment through the VPC peers to the shared services repository and then to production. So that becomes an attack vector in and of itself. You've now just connected dev and prod together. So what you need to think about is, what firewall rules do I put in place there? And you can look at things like the principle of least privilege. This is the idea of giving things the minimal amount of permission and information and agency that they need in order to achieve a certain goal. So your CI/CD pipelines tend to have what's called a build agent or a runner, which is an individual machine who is going to execute some jobs. And this helps them scale to the level of capability you require. In order for the build agent to run and to do its job, it needs to be given a service account. And a service account is just an account which requires authentication and authorization to do some piece of functionality. And in cloud environments, those service accounts achieve that by being assigned IAM roles. So they'll have a set of permissions which detail what they can and can't do. By default, IAM roles in cloud environments tend to be quite permissive. If you see names such as owner or editor or even admin, they're probably too permissive. So what I like to do is I like to create different build agents for different purposes, assign them different service accounts which have the fewest amount of IAM rules that they require to get their job done. So that allows me to have a build agent which is responsible for building code and can push it to a container registry, but it can't do dev and prod deployments. I would have different build agents to do a deployment. Actually, I'd have different build agents per environment. So if any of these get compromised, it basically just limits the blast radius of how much damage they can cause. If somebody is able to run arbitrary code on that build agent, well, they can, but they can only really, if it's the one that's doing compilation, they can really only push to an artifact repository. They can't then put it into production. This makes it more difficult for an attacker to get around your system. But one of the important things as well is you need to make sure that the logs for all this stuff is preserved. So if there is an incident, you can look in your logs and see what's gone on. But crucially, you need to make sure that these actions are tied back to the user, not just the service account. And that's something I fell afoul of before. So you need to make sure if a build agent is performing a certain job, you also log, okay, it was Sam who triggered this. The pipeline connects to a repository, and typically what you want to do when you set up a source control repository is impose some kind of structure to that, which represents which code is ready for production, which code is kind of being considered for active development, which stuff is still work in progress. And pipelines will let you place restrictions so that, let's say, only commits to the main branch can be pushed to production. Only commits on the develop branch can be pushed into the develop environment. Commits on a feature branch, for example, you might allow those to go to develop, but they might have kind of ephemeral environments. So that's kind of fine. You need to make sure that somebody can't just kind of create a branch and yeet some code into production. But one of the really nasty things with this is you also need to make sure that nobody can just fork your repository, inherit your pipeline, and then commit to that and kind of bypass all of your controls. So a lot of if you're using a service like GitLab or GitHub Actions, you'll probably get this for free, but it's always worth checking basically the provenance of any source code that is triggering a pipeline job. Ultimately your branching model in the repository reflects what can and can't be done, and you may kind of also make it so that certain branches don't do certain pipeline jobs. So like you may say, if somebody's committing to a feature branch, we probably don't need to bother going through all the vulnerability scans at that point. We'll do that a bit later. It's entirely up to you, but you need to make sure that your pipeline is sufficiently set up to reflect how you want code to make its way to production. Okay, I want to again talk briefly about container security, because everything is kind of going the way of containerization, and that's cool, but there is a few things you need to be really careful of if you're building containers in a pipeline. So the first one is, if you're running something like Docker build to build a Docker image, if you can run Docker build, you can also run Docker run, and if you can run Docker run, you can execute arbitrary code in that machine. So ultimately, the way that works is when you run one of these commands, you're effectively sending that instruction from your terminal, from your user and process space, to a Docker daemon, which then runs the image itself. As it currently stands, the Docker daemon runs as a root user. It needs to run as a root user because one of the way containerization works is by creating C groups and namespaces, and you need to be root to do that. Crucially, unless the containers have been set up correctly, the default user in the image will be also running as root, and that makes sense to a certain degree. So if you have a Docker file which says from Alpine, and then the next step is run apt-get, well, you need to be root in order to install any software. But when it comes to actually running the container, if running as root is generally a bad idea, it is possible for a process in a container to break out of the container, and if it does that, it's then running as root on the machine, and if it's running as root on the machine, it's completely compromised. So again, this is where your Docker security vulnerability will come in, but you need to make sure that you don't run as root within a Docker image. So there's a user command which will let you change the user to a different one, which will let you kind of specify it on with fewer capabilities. There are also tools out there which allow you to do Docker builds without running root. So you can look at Builder or Podman. If you're running your CICD pipeline in a Kubernetes cluster, then Google have a project called Canicore, which don't require root for that part of it, and that can help kind of minimize the risk of somebody building and injecting malicious code. But one of the other things to think about with containers is that they're a unioned layered file system. So if you start with a Docker image that says from scratch, and then Alpine sits on top of that, and then Node sits on top of that, and then your app sits on top of that, what happens is the file system basically gets collapsed down. Let's say it's one of those steps you kind of inject some secret value, and then in a later step you delete it. Those will create different layers in your Docker file system. And that might look on the surface like that file's gone. If you then kind of run a Docker integrated terminal against that image and kind of try and do something like ls and print the directory that has that secret, you'll see it's not there. And that might make you think that that's gone, it's secure. Actually, what you can do is you can run Docker inspect, and it will effectively give you a tarball which contains all of these layers of the file system. So if there's something secret in one of these layers that later gets deleted, it's still there. You can still see it. You can just need to run docker inspect. And I honestly recommend just grabbing a Docker image off the net, running docker inspect and playing around and seeing what's in there. You will genuinely be surprised. Which brings me to the next thing about artifact storage. So your pipeline is going to build something and you then need to put it somewhere. So how are you going to do that? One of the things that you can do, well, if you're going to build something, firstly, you need to pull in your third-party dependencies. Do you pull that in directly from a public repo like npm or Docker Hub? The thing with doing that is if somebody can view all of your network traffic and they see a whole load of requests going out to npm or to Docker Hub, they know that they're going to be returning executable libraries. And if they can poison that in some way, they can inject malicious code into your application. But if you remember the LeftPad scenario, where a LeftPad was a very small JavaScript library, but it was used by so many libraries who were then used by so many applications that when LeftPad got deleted from the internet, all of a sudden, a whole load of people couldn't build their software because a dependency of a dependency had just disappeared. If you're running from a public repository and you're pulling in all your third-party dependencies that way, well, you're completely vulnerable to that. So what a lot of enterprises do is, in addition to having a private repository that they host, which stores binaries they've built, they will also have a mirror of third-party dependencies and will typically block direct traffic to one of these external source control repositories. Yes, that can be a pain in the arse because it can mean that you then need to raise a ticket to a security team who need to inspect a library and pull it into the golden source approved third-party repo. And keeping those dependencies up to date can be a pain. You need to work out your own level of comfort with this. Some can be set up to automatically proxy a public repository. So if you hit your internal Nexus instance with a carefully constructed URL, it will pull that in from the public repository, run a couple of scans, and if it's fine, it'll put it in, so you don't need to raise a ticket. You also need to think about, well, if I build an artifact, that might be a work in progress artifact. That might be something that I want to deploy to a dev environment, but it's not necessarily production ready. How do you distinguish between what's dev and what's prod ready? And how do you make sure that you can't deploy anything that hasn't gone through the full quality process to the production environment? One way of doing this is within your artifact repository, having different kind of groupings or using different labels, and your pipeline can check, does this artifact, is it a Docker image or is it a jar file or something? Does it have the appropriate labels on it? And if it doesn't, I won't deploy it. But actually on containers again, one thing to be aware of is when you're building a Docker image, you occasionally will give it a tag, and that tag could be the version number. Those tags are mutable, so you can push another Docker image and give it that tag, and the old tag from the old image will disappear and it'll be repointed to the new one. And there's good reasons why you'd want to do that. So latest is a good example of a tag which always moves, and you get the expectation that whenever you pull that Docker image with the tag latest, you're going to get the latest thing. That makes sense. You may also want to do that if there's a vulnerability in a build artifact you've produced and you just want to be like, okay, let's just repoint it to the fixed version so that anybody who pulls this is going to get the fixed one. But it raises an interesting challenge. If you're building a Docker image, how do you know that the image that you built is the same one that you're then coming to deploy later on? Now, that might not matter to you so much, but if you're in a financial institution, I guarantee you do have to have those kind of assurances. One of the things you can do with Docker is the Docker image itself will have a SHA-1 fingerprint, just like a Git commit does. And that uniquely identifies that Docker image. It's called its digest, and you can refer to that Docker image via the digest rather than via a tag, and that will cryptographically guarantee that the same thing you built earlier on in the pipeline, if you pass the digest file all the way through, is the same one you're deploying. But you need to be able to answer these questions because you don't want somebody to basically push up a malicious binary, change a few tags, and all of a sudden that's just going to be automatically deployed to production unchecked. And the last thing I want to cover is secrets management. Now, this is a talk and a half in and of itself. We've already covered how you shouldn't hard code secrets into your application and put them in your source code repository. So we've covered that. Don't do that at all, because it basically means if they need to be changed for whatever reason, you need to completely rebuild and redeploy your application. So what else can you do? Well, your pipeline can inject environment variables to the application, so you can pass in secrets that way. And there's a whole load of tools which expect things like database passwords to be passed in this way. Pipeline tools such as GitLab will allow you to mask these environment variables so that they're not present in logs, which is really cool. But you still need to think about that in general. Are environment variables going to be visible plain text in your logs? And you might think, okay, well, at the point where I call docker run -e foo equals bar, I can obfuscate that with a regex or something. But you've also got to think about what happens if your application blows up, because what occasionally happens is they'll print out the stack and they'll print out the context in which they were running, which will be the environment variables. And are secrets visible in plain text if you do that? That's a really common way for somebody to get at secrets in your application. And like we said before with Docker Inspect, environment variables are visible through Docker Inspect as well. So you've got to make sure that if the environment variables are specified in a Docker file, yep, you're going to be able to crack all those open. So what else can we do? Well, we could use a tool like a secret manager, CyberArk, HashiCorp Vault. There's Amazon Credentials, there's Google Secrets Manager. There's a whole load of these. These are encrypted storages for secrets. And the cool thing about them is you can apply individual policies to individual secrets. So you can say, this database password can only be accessed by service accounts who have this IAM role, or this private key can only be accessed by this service. So you can have kind of really fine-grained policies on who can access what individual secrets. They also have really cool things in, like HashiCorp Vault, for example, can automatically rotate database passwords every time they're used. So every time you want to connect to the database, you're going to get a unique, temporary, short-lived key. Or you can set custom expiration policies for other secrets so that they just get rotated behind the scenes, which is really cool. And what that means is they're stored encrypted at rest. If your pipeline can make a HTTPS connection to the secret manager to get the secret, then it's going to be encrypted in transit, and it can then feed in the secret to your application. Things like the 12-factor application manifesto, guidelines, whatever it is, will say that you should store config in your environment, which kind of leads to passing config in through environment variables. So you can definitely do that here. You could definitely get the secret from the manager and pass it into the app in exactly the same way. That's cool. You've got to think about all the same things with environment variables if you do that. Are they visible in the logs? Are they going to be printed if they're blown up? If the application blows up? So one mitigation against that, for example, is through key rotations. That if somebody does compromise a key, it's possible to just rotate it, and that key is no longer going to be useful for anything. Your application can either be redeployed or it can dynamically adjust to the new key if it's set. So I've started moving away, where possible, from passing in secrets in environment variables. And what I try to do is actually delegate this away from the pipeline completely. So if possible, I would have the application itself connect to the secret manager and pull in its config. That way, the pipeline isn't involved. All it's doing is it's starting up the application in the right context, and the application it'll be running on a service account effectively. It can then connect to the secret manager. that means within your application, you can do things like, pull a new secret every half an hour or whatever your time to live is, and dynamically adjust if you get a new value, so that if you have to rotate the secret in your manager tool, your applications are just going to pick it up and work. Slightly running out of time, so just to kind of summarize this, these are just mistakes that I've made along the way. There are probably tons more, and you can go into a huge amount of depth on all of this stuff, and you could still find more stuff that you need to do. Like I said, the important thing is thinking about it, asking the right questions, understanding how at risk are we to this particular threat. Do we need to mitigate it? Are we comfortable with it? Do we want to go full hog and really lock this stuff down? The key thing is your application is an asset, but so is your CI/CD pipeline. And for that reason, it's an attack vector. So what you want to do is you want to think about things like threat modeling, apply defense in depth, apply the principle of least privilege, limit the blast radius of any damage in your application, and that will put you on a really good footing. Okay, so we have some time for questions. That's my website, that's my Twitter handle. There's blog posts on there. You'll get the slides when I put the recent version on, and also all the Halloween pictures, which is what anybody wants. So yeah, thank you very much, and I'm happy to take any questions you have.
Hi, that was a really interesting session you've had there. I'm just looking through the questions that we've had coming through. I think a key one's coming through is, do you sort of favour any one particular sort of CI/CD process, tools, chain that you think does the job better to secure the pipeline?
My experience is mostly with GitLab, and I like GitLab because it has kind of templates which let you pull in SAST and DAST and container scanning, so it gives you a lot of that stuff for free. For that reason, I really like it. Interestingly, it runs each individual job within Docker images. So that's kind of how I started thinking about the whole Docker containerization thing, because basically the unit of work in a GitLab pipeline is a Docker image. I'm starting to use a bit of Jenkins within my current role. I haven't had a look at things like Azure DevOps yet, which kind of are very tightly integrated into a particular cloud provider offering and will abstract some of this stuff away from you. I think the best thing to do is really kind of think about, do I want to go all in on something like Azure or AWS, and am I happy to delegate not just the running of my software, but the building of it to that cloud provider as well? Or is this something I want to control myself somewhere independent? And so yeah, most of my experience is with GitLab, and I that's a mostly pleasant experience. I would say it's definitely nice, and because it's really tightly integrated into your source control repository, because it does both things. It's kind of nice. You can place some really fine-grained permissions on which branches can be deployed to which environments, and tie that into things like branches need code review approvers and only certain people can merge to branches. So it just gives you a lot of comfort, I found.
It's interesting watching the GitHub Universe conference this week. What a big investment they've made in all of the tools that sit around the edge of the pipeline. But they're not in your control, are they? At that point, you're not choosing. So it's very much reflects back on what you've just said.
Yeah, and actually that's one of the things about GitLab. So with GitLab, they have shared runners. So there's basically a bunch of compute resource somewhere that if you want to create a GitLab pipeline, it will just run on these machines. And that's kind of okay. You get some benefits of containerization, but actually that's somebody else's machine, and you may not be comfortable running your code or deploying to your environment from those machines. So that then goes down the self-hosted route, and self-hosting is cool, but it comes with its own operational challenges if you want to do that. And I think I don't know a huge amount about GitHub Actions, but I imagine there's a very similar setup going on there.
Yeah. Right. Well, I think given that we had a slightly late start on this one, we better give people some time to go and get a coffee and get to their next session. So thanks, Sam, for that really interesting session. And as you can see, his details are up there, and I'm sure happy to take any questions via any channels that are open.
Yeah, and I think the recording is going to be available. I'll stick the slides on the site straight after this, so you'll have them.
Okay, thank you, and enjoy the rest of your day at DDD.
Bye.